Okay, hello everyone. In a new video. In this one we are going to solve an exercise related to mechanics in the chapter of kinematics for grade 10 students. Exercise number 3. The time equation of a particle P in the space reference system OI is x is equal to t square 2t square plus 40 minus 6. Number 1. When does P pass through the origin? And here 1 refers to time. So we need to determine the value of t when P passes through the origin. Now the origin corresponds for x is equal to 0. So we need to find t when x is equal to 0, knowing that the origin corresponds for the equation x is equal to 0. So x is equal to 0. Now replacing the value of x by this expression, so we need to solve this equation for t, because they are asking us 1, and 1 refers to time. So we need to solve for t in order to determine when does P pass through the origin. Notice that here they are telling us, given that t minus 1, t plus 3 is equal to t square plus 2t minus 3. So this is the expanded form, and this is the factorized form. Now notice that what's the common between this form and this form? We can notice that if we take on this side 2 as a common factor, we have t square. So 4 divided by 2, we have it's plus 2. 6 divided by 2, we have it's given by minus 3, it's equal to 0. Now we can notice that this form is identical to this form. And now if we replace the expanded form by the factorized form, then we are able to solve this equation. So how do you solve this equation? By factorizing it. So we have 2 multiplied into t minus 1 to 2t plus 3, it's equal to 0. So what's the solution of this equation? So t minus 1 is equal to 0, or t plus 3 is equal to 0. Because for sure the number 2 is different than 0. So in this case, the solutions of this equation is given by t is equal to 1, or t is equal to minus 3. Why or? Because it's equal to 0, so it's sufficient that the first factor must be equal to 0, or the second factor is equal to 0. Now notice that here time, sorry, I didn't include any unit. Let me include the units. So the solutions of this equation are given by t is equal to 1 second, or t is equal to minus 3 seconds. But we know that time can be only positive, so this answer is accepted and this answer is rejected. Then in this case we can say when t is equal to 1 second, P passes through the origin. Now as for number 2, where is P at t is equal to 2 seconds? So here they are giving me the time and they are asking me where refers to the position. So we need to find the value of x when the value of t is given by 2. And this can be done by referring to the time equation of the particle P. So we know that x of t, or x for short, is given by 2t square plus 4t minus 6. Now the value of the time is given by 2. Now replacing t by 2, now plugging this expression on the calculator, then the value of x is given by 24. Since everything previously is expressed in SI, which is meters and seconds, so the value of x will be expressed in meters. Then x corresponding for the position of the particle t when the time instant is given by 2 is given by 24 meters. And now as for number 3, indicate with a justification the nature of the motion of P. So indicate by itself, it means that we need to state with a justification. So the nature of motion can be identified by referring to the given time equation. So notice that in this case, the quadratic term, which is given by t to the power 2, exists in this equation. So it verifies the general equation, which is given by x is equal to half at square plus v0t plus x0. So let's say since the given time equation verifies the general form x is equal to half at square plus v0t plus x0 with. Now, so in this case, the type of motion is given by UVRM. So it's either UARM or UVRM, and this depends on the sign of the acceleration. So the acceleration corresponds for the quadratic term, and notice that in this case this is positive. Then we have with half a is equal to 2, then a is equal to 4 meters per second square, which is the SI unit of the acceleration here, because everything is expressed in the SI. So it means that this is positive. Then the type of motion is UARM, because the acceleration is positive. And now as for number 4, we need to determine the initial position and the initial speed of p, and this can be done by comparing the general equation with the given time equation. We have that x is equal to 2t square plus 4t minus 6, whereas the general equation is in the form of x is equal to half at square plus v0t plus x0. Then now we can say by comparison, now the initial position correspond, or the speed correspond for the linear term. This is the linear term. Comparing both terms, we can see that the value of v0 is given by 4, and the SI unit of the speed is given by meter per second. Whereas the initial position correspond for the constant, and the constant in this case is given by minus 6. We don't forget the minus sign. So x6 is equal to minus 6, and the SI unit of the position is given by meters. Now as for number 5, part A, verify that the acceleration of p is given by a is equal to 4 meter per second square. So this is done. In part 3, we can say between brackets done in part 3. Now as for part B, we need to verify that the speed of p at any time t is equal to v is equal to 4t plus 4. And this can be done by referring to the nature of motion. So since the nature of motion in this case is given by UARM, then in this case we have that v is equal to at plus v0, but we know that the value of the acceleration is given by 4 meter per second square, and the initial speed is given by 4 meters per second. Then in this case we have that the expression of v as function of time is given by 4t plus 4. Now as for number 6, calculate at t is equal to 3 the speed and the distance covered by t. So let's start by the speed. At t is equal to 3 seconds. So we have that. Now we need to calculate the speed knowing that we have time, so we refer to this equation. Now replacing the value of t by 3 and plugging this expression on the calculator, we have that the speed at the instant given by 3 is given by 16 meters per second. So v is equal to 16 meters per second. Now as for the distance at t is equal to 3 seconds. Here we need to be very careful because the distance is given by d is equal to x minus x0, another position. So we need to calculate d is equal to x minus x0. We know the value of x0 to be given by -6. It is left to determine the value of x at t is equal to 3. So first, let's determine the value of x at t is equal to 3. Now plugging this expression on the calculator, then the value of x is given by 24. Since everything is expressed in the SI, so the value of x will be in the SI, which is meter. Now we are ready to calculate the distance, which is given by x minus x0. The value of x is given by 24, whereas the value of x0 is given by -6. Now plugging this expression on the calculator, then the value of d is given by 30. Since everything previously is expressed in the SI, so the value of d will be in the SI, which is meters. So the distance covered at the instant t is equal to 3 seconds is given by 30 meters. So that's it for me in this video, guys. I hope it was beneficial for you guys out there watching it, and see you soon in another one.